At the end of your life, what will be your legacy? What will you leave behind for future generations? For the world, join the World Messenger, Isabella Lundberg, each week as she brings you a new distinguished guest from the business, sports, or entertainment world to share their success, their struggles, and their lessons. They will share their insights into current hot topics that affect everyone. Isabella facilitates an intimate, vulnerable environment to find the true value of humanity and real leadership. Are you ready for your legacy? The legacy that matters?
Hello, hello, my beautiful friends. It's Isabella Lundberg here, and I'm inviting you for another epic episode of the Legacy Leader Show. I am absolutely thrilled to introduce you to today's guest. Our guest is joining me here from Louisiana. He is not only amazing in science, technology, innovation, he has over 24 patents under his belt. He's also a phenomenal musician who is creating music and play all kinds of instruments, but also has one of the best critical minds I had a chance to be exposed to. Without further ado, let me introduce you to Ronald Lewis. Ronald, how are you?
Hey, Isabella, thanks for having me here today. This is awesome.
I am so thrilled that we're finding time to get together, and specifically right now in the light what is happening this weekend, that we're celebrating Memorial Day weekend. People are traveling, doing all kinds of things, and you finding time to give back. So first of all, thank you. Second, I heard from a couple of mutual friends that not only you served, but you did some amazing work while you were serving. So before everybody that's watching and listening, do you mind tell us a little bit about your background and your service that you did so that we can also not only thank you for what did you do to protect this country and continue to do, but also some interesting story related to that.
Sure, absolutely. Okay, so when I joined the Air Force, it was kind of funny and kind of interesting. I'm fairly small. I'm 5 foot. Well, but then I was 5'3". I was in a really bad motorcycle wreck, and I was in traction. So now I'm 5'4". So it wasn't all bad. Um, but 5'3", 90 pounds, and the Air Force looked at me and said, "You would make a great law enforcement officer." That was extremely challenging for me, as you can imagine, because I'm a geek, I'm a bookworm. The last thing I was law enforcement material. But what was interesting about that is that was in the 80s. Fast forward to the 90s when we were building this little thing that we call now the internet. I was working with the Air Force and got to do some really interesting stuff around how do you secure this thing that we now call the internet. And so I got to use a lot of that law enforcement disciplines to help design what we currently have today. The things, the techniques and whatnot that we use, and I always use the example of port scanning for open ports. As a law enforcement guy, we used to do what we called shake, rattle, and roll. And shake, rattle, and roll is now an important part of pen testing, right? And shake, rattle, and roll is when we would take the squad car, we'd go to a building, we'd shake all the doors, rattle all the windows to make sure they were all locked. And then we'd hop in our car and we'd go to the next building to shake, rattle, and roll. And a lot of that is a lot like what we do in cybersecurity today, where we do shake, rattle, and roll, looking for open ports, looking for unauthorized services, and looking for overall vulnerabilities within the security architecture. So.
That is so fascinating and so much involved, but I'm also glad that you share a little bit of that story, how you with what many avenues will not necessarily be the perfect fit for different roles. You find your way not only to get selected, but also to make tremendous impact so early on. Have you served anywhere outside of the United States in Air Force capacity?
So my first assignment was in Belgium, and so that was very interesting, because I grew up pretty much homebound, lived in one city and actually never left my neighborhood. Suddenly I was overseas, living in a strange land where they didn't really speak the language. And that was pretty interesting. And I learned so much so quickly. You have small fish in a big pond. So I served there. I joined the Air Force. It's funny. I joined the Air Force to see the world. So I grew up in Texas. As you know, 5'3", 90 pounds, it grows big in Texas. Moved to Belgium for a year, served there for a year in a law enforcement capacity. And then the military sent me right back to San Antonio. So much for seeing the world. Um, And then after that, I got moved to Alabama and I became a defense contractor when I got out of the military. And the funny thing is I got sent through an Air Force program. I helped re-engineer a lot of the base networks. And in 2000, I actually did go see the world. So I took something like 36 trips, most of which we used to say were across the pond. And so I spent a lot of time in Germany, spent some time in Turkey. I got to go all over, spent some time in England. So that was nice.
That's a great way to get exposed, but it's also great to continue to understand the pulse of the world and what world needed the most. But I'm curious, Ronald, you did something incredible based on obviously being able to tackle in technology and diversify. And you pioneered in AI and other now trending technologies and automation and machine learning. So do you mind shed some light? First of all, how did you get involved into that? And what was that experience? And how this fast forward, where we're here today, what do you see happening?
Interesting. So back then we didn't call it artificial intelligence, right? Because but it was non-deterministic in nature. And so because it was non-deterministic, we used the term, and perhaps you've heard this before, fuzzy logic. Because when you talk about logic, it's usually deterministic, right? And so it's a 0 or a 1. And AI is not 0 or 1, it's probabilistic in its nature. And so we called it fuzzy logic because it was almost 0 or maybe almost 1, but neither. And so back then the Air Force had a goal and we wanted to build computers that could program themselves. And so all of that was, so very data centric. I'm a logical guy, love chess, terrible at it, love music, mediocre at it, and so all of those things together, the Air Force was like, how would you feel about being part of this program? And you would be the data guy. So my job was to take this legacy Sybase, right about the time that Microsoft and Sybase were working together to create what we now know as SQL Server. I was using a Sybase database, and we would take all this proprietary data from all these different tools, and we would integrate that data. So we would be able to take a picture like an architectural blueprint, scan it in, feed it into the computer, and then take all of this data from the tools that the computer would derive from the picture. And then we'd start putting it together to start building, or we wouldn't do it so the computer could start building the systems. That was my first foray. AI is very data centric. And so it's interesting that, today you'll see, a lot of heavy focus on data centricity. I'll tell you the biggest challenge that we have with AI today, and I think it's where we're missing, is AI engines today require so much data to make decisions. And there's a very interesting trend in technology that is largely ignored. And so we hear a lot about big data, and that's where the big heavy focus is. But it's interesting because I'm following the little data approach, where it's the right data put together on a very smaller footprint. And so you see in industry, and we're heading towards this catastrophic cliff that, big data requires so much data and so much electricity that we can't sustain that. That's not sustainable over time. And then you see this little data movement. And so you see trend is driving bigger and bigger bandwidth, more and more data that, and big data pushes, big bandwidth needs, big data needs, drive big power needs. And I think that's a road that's going to end up being hard to sustain. And so as we get better and better at AI, you'll see the data foot start to shrink versus grow. And so that's kind of, to me, the measure of maturity. And so that's also where I'm kind of finding myself spending some time working.
And with
I don't know that I answered the question, Isabel.
Yes, you did. And understanding now, obviously, the shifts from, I love that you mentioned importance of quality of data and also sample of the data. So then when we have that, what can we then tell and what can we also predict? And when we have a over period of time, then it's, in my mind, also very useful and effective. And a lot of times we're seeing, specifically with larger companies, that is not the case. And a lot of data and analytics really can tell you only partial and not fully holistic picture of organization or situation you're dealing with, which can be very risky and very challenging. I'm curious, how do you see current AI evolution? And in my mind, also revolution to that. Now it's going to 3.0 version for much more advanced mindsets and also organizations who really already establish themselves. What do you see coming and what we need to pay attention to?
It's a question. Okay. I'm going to start by saying something that may be a little controversial, and hopefully nobody hates me. But when you stop and think that we have this idea that if you take, and data warehousing is a good example of that. We have this idea that if we put enough data together, that patterns would just suddenly show up and give us new meaning based on the data. And I'll tell you that that's kind of a that's kind of a panacea that just isn't real, right? It's kind of, that doesn't happen. And I know, and occasionally, and there's, don't anybody flame me, right? There's a couple examples where maybe that did, but that's the exception, not the rule. And so we have this idea that if we put enough of our data together, we'll be able to put an AI overlay on top of all of that data. And these meaningful data patterns will just kind of like make themselves real to us. And so when you realize that companies spend a lot of money on putting all of the data into a data warehouse, and usually there's not only one, right? We go, okay, well, this data warehouse didn't show us what we thought we would find, so we'll build another one. And Einstein said that the definition of insanity is doing the same thing over and over and expecting a different result. 80% or more of the work that data scientists do is thrown away, and only a very small part of that realizes value for the investor. And so clearly that's something that needs to change. And so as I'm looking at AI, so what are the AI trends? So again, we go back to the mindset of if we put enough stuff together, something magical will happen, and I don't think that's true. And so what I see happening is I see smart companies being a little more strategic about their data warehousing initiatives and the AI overlay, right? And that's a difficult pill to swallow sometimes, because what we're realizing in industry is that there is no magic with data. Everything is still use case driven. What is we see this in ChatGPT, right? It's like, you don't come to ChatGPT and you type in, tell me something magical. you type into ChatGPT a specific question, and you put your prompts into ChatGPT very strategically, very, very discreetly. It's like, tell me, and then you put some very well-defined, because if you're not very specific about what you ask ChatGPT, the quality of what you get out of ChatGPT is, questionable, right? And so I see that as a big trend in AI. So if I was going to harp on anything, it would be, let's be a little more use case specific about the problems that we're trying to solve. Let's be a little more careful about what we're doing with all of the data. And so I think about all of the big breaches too. So what are we doing? We put all of this data together. Are we finding magical meaning? No, we're building these really high value targets for enemies and for hackers to make lots and lots and lots and lots of money. So
that is a great point, and that really brings another area of your expertise, which is security. And you obviously now not only understand the actual systems and softwares and what's available, and now these new emerging types of technologies, but all of them ultimately, as you said, have to serve the purpose for key stakeholders. So looking from security standpoint, do you mind shedding some light? How do you see now one of some of the biggest vulnerabilities that we need to pay attention, specifically from C-suite executives, CXOs? What do they need to understand better, do better, and then also position to be able to protect the most important aspects of their business?
That's an amazing question. So I usually hear it put this way, right? Someone will come up to me and go, okay, you do a lot with security. You look at a lot. What keeps you awake at night? And I go, what keeps me awake at night? The question should actually be, what do I know that should keep you awake tonight? Right?
Brilliant.
And And yes, there are things that keep me awake at night, and I'll tell you that some of the things that keep me awake at night are, again, going back to the convergence of data, but more importantly, cyber physical integration. That terrifies me because I worked at a university. I taught fundamentals of reverse engineering, and man, I taught the students how to take, IIoT and IoT devices, which represents the convergence of cyber and physical, the cyber domain and the physical domain. And man, the stuff these kids would find is terrifying. So like there's very popular cameras, I won't mention the name. But if you pull their mobile app apart, the key to the cloud storage is in the mobile app. And you can use it to gain access to, everything, in the cloud. And so for obvious reasons, I'm not going to give the name of the camera. But I mean, these are the kind of things that keep me awake at night. But from a C-suite perspective, okay. So what keeps me awake there and what should keep every C-level awake is, you heard my phone just ring, all of the software on these, all of the software on the laptops, all of the software in the cloud, every software, 98% of all software packages are driven by open source. Now, I'm not saying we need to pump the brakes on the open source movement. I think that's very important from a momentum perspective and being able to get things to the field. But the amount of risk, it's not the known risk that worries me, it's the unknown risk. And I'll tell you that there is so much unknown risk with open source, and I believe it's deliberate. I think we talked about AI. And so using an AI to evaluate code commit trends to see what, these different nation states are doing from an open source perspective is terrifying. And what that means is, this allows, enemy nation states to not just control the wire, but to control the endpoints as well. And so that keeps me awake. And then, there used to be a Prego commercial. I love the Prego commercial where it's got this guy and he goes, "It's in there," And so it's like, "Are there tomatoes?" "It's in there," And so as we start looking at the software ecosystem, that's the scary part. Buffer overflow, it's in there. Unsanitized input, yeah, it's in there. And here and now, security guys will tell you, well, those are happy little accidents, happy little mistakes made by a developer. And then we go back to, and I always use this as an example, DPDK, right? The data plane developers kit is in anything that's, that powers software-defined networking. And DPDK is heavily influenced by, enemy nation state military, right? Programmers for the military is #1 contributors into this DPDK. And yet, you use NSX with VMware, you're using DPDK. The Cisco iOS, heavily dependent on DPDK. You saw Versa was recently compromised and these little telecoms were exposed. Well, guess what? DPDK, right? And so, and that's just one example. Linux Torvalds client kernel, right? The Linux Torvalds client is another that we see a lot of military contributions from enemy nation states, right? It's like, ooh, that's kind of scary. Should that keep us? That should keep everybody awake at night, right? I mean, whether you understand code or not, it's like the ultimate Trojan horse. Now, am I saying pump the brakes? No, but know the risk. Be a little more selective about what's, when you're cooking in the kitchen, you want to avoid the arsenic. It might be in the spice rack, but you might not want to put it in your food.
You want to make sure, first of all, it's eliminated from that spice rack, but if it's there, you need to know and properly label it and know what you're looking at, right?
Yeah, there you go. So
I love that analogy. That is very visual, and it also helps to break down complexities that we're dealing with, right? And ultimately what is coming. So now understanding with data, with analytics, with all these new emerging AI and machine learning and automation concepts that are happening, right? And the rapid speed of it, it's also huge concern on top of everything you just mentioned.
I see several catastrophic conditions on the horizon. Three fundamental areas. And so from a compute perspective, you mentioned AI. So AI is expensive. The power requirement, the power consumption trend that we're on from a compute perspective, not sustainable. So I've got a patent in the works. It's on a hybrid compute plane working with Louisiana Tech, on the university side, working with the students there. And so there's a patent in the works there that allows us to use the right types of compute in an orchestrated fashion that reduces computational complexity and the associated power consumption by about 90% or so. That's pretty awesome. I see the data proliferation from a cyber physical integration perspective. Our devices are aggregating so much information about us, so much metadata, so much raw data, and all of that's going into a surface that's very accessible, and we're being sold. And so from a data perspective, that worries me a lot. There's a catastrophe waiting there. We just had one with the data breach, where a lot of our personal information, like social security numbers, have been compromised, and all of that terrifies me from a cyber physical integration perspective. And then from a security perspective, the whole attack surface. No one is looking at the attack surface. Everyone is looking at the vulnerability surface and going, what are the vulnerabilities I should be watching for? It's like, no, take a step back, take a look at your attack surface. Those are the three big things I see on the event horizon.
That is a great insight because, again, because of speed and delays in decision making and making the right type of decision, we're seeing three major problems, right? It's like, first of all, it's like no action, a lot of reactive approaches. And when they are now finally taking some actions, most of the time they're not the best ones to move forward, which also shows the gap in knowledge, gap in understanding, and also skill set from the team and advisors and people in the arena. So it's very hard to depict, right? And what makes sense and who to listen, because it's so much out there. So do you mind share a little bit perspective on that? And then we can dive into your amazing patents, because I cannot wait to hear that.
So we do a lot of data driven. So the big push right now is data driven decision making. And I don't think that's wrong. I think that's right. But if I can make a t-shirt or a bumper sticker, this would be my bumper sticker. Data matters, right? Because it's not just data, it's the right data, making decisions based on the right data. I mean, I could give you plenty of examples where I made big decisions with the wrong data, and it's like, I should have made sure I was using the right data. I go back to my first concern with data science is like, okay, we're going to magically put all this data together and then we're going to make a decision based on a trend that we see in the data. But what if you're looking at the wrong data? And so I think about, there was this tool called Pinecone, the father of data warehousing, Bill Inman, created this, Bill Inman claimed to fame, love him. I used to speak at conferences with him, but Bill Inman, father of data warehousing, built the first data warehouse for Walmart. And from a supply chain perspective, and you saw what he did. I mean, he put Kmart out of business almost overnight, all these things. And so he was real curious about how successful his warehouse was. And so he built this little tool called Pinecone to look at what data was actually being consumed to drive decision-making from a supply chain perspective. And you know what he found? Only 6% of the data in the data warehouse was actually being used for decision-making. But look at the impact of that 6% of the data. So I go back to, they were looking at the right data for driving decision-making. So putting all that data together, great. Using the right data makes all the difference in the world. So it's not just, and so a lot of decision makers go, we'll build a data warehouse and we'll use it to drive decision making. But let's take a step back. What data are you using to drive those decisions? And then from a cost perspective, what is your data warehousing initiative costing you? And do you really, so that's the other thing, cloud. I love cloud, but you know what cloud creates? Sprawl. Cloud is messy, right? It's like,
Yeah.
I don't have to worry about storage space. You know, in legacy, I'm
Just
looking
dump it
around.
there.
Yeah, we'll just dump it there. I'm looking around my desk and I have a bunch of these laying around, right? Because this is cheap storage. This is an SD card, by the way. I don't know if you can see that. And so it's like, oh, I need more space. In cloud, that's not an issue. I have to be very specific about, because I do a lot, right? I've got my desk is a mess. There used to be a commercial about messy Marvin, that's me, right? So it's like everything everywhere and all at once. And so with cloud, there's sprawl and it's a big problem. And so we just keep putting more data, we keep putting more stuff and building more services to expose data, and things get everywhere, right in the cloud. And so cloud spend is out, off the charts. And it's like, well, I go back to what Bill Inman discovered, and I don't think he's wrong. And I don't think that has changed. It's like 6% of the data is meaningful and can drive, good decisions. And so it's like, hey, well, maybe we should take a step back. Again, I'm not saying we shouldn't be aggregating data, but I think we should maybe being a little more strategic about what it is that we need. And so I go back to what are the decisions that we're trying to make? What is the data that lends itself to making those decisions? Because the last thing you want to do is take a whole bunch of data samples and put them together and come up with the wrong outcome. And you're making data-driven decisions, true, but are you making the right decisions with the right data? And so that's my big concern about data-driven decision-making. I think that's 100% important. I think the industry is moving in the right direction, but I go back to what is the data that you need to solve the problems that you're trying to solve? And I have a patent on that, by the way. I built a really cool data semantic layer that allowed so the automatic data ingestion, automatic data cataloging. I've spent a lot of time studying this problem, right? And so the outcome of that was a really cool Air Force project. Air Force did some really, forward-thinking, industry-leading work there, and they funded this really cool creation of this data semantic layer that essentially automatically derives using AI, an enterprise thesaurus. And it allows, you to take seemingly unrelated data from, unrelated systems, and then from a business context perspective, align those semantically so that you can start putting the right data together to make the right data decision. So that was a lot of fun.
And I just love how you see the problem and see opportunity and then leverage all this exponential over the decades experience to create a solution. So obviously you have over 24 of patents, and that blows my mind. Just that fact alone, in addition to all this tremendous work that you already achieved and continue to do. So how did you, first of all, before we go to figure out what patents and what some of the great solutions are there, how did you get into patent concept? Because for a lot of people, it's like, wow, do you know what's the great idea, a great solution that deserves to be patent, and then let alone to have over 24 of them?
Oh, yeah. So, okay. So, I get bored very easily. I don't know if you picked up on that. And I love to do different things. And I had an amazing opportunity at a very large telecom. I was doing security work for them. And the guy that ran their disruptive innovation division was a guardsman in the army, and he got deployed to the Middle East. And because I was doing the security work on all of his projects, I said, hey, can I just step in till he gets back? And can I help, since I'm infinitely familiar with all of his programs, and I have a pretty broad berth of experience in technology. So the telecom put me, and they actually created a new division for me, and I was the director of disruptive innovation. And I used to mentor, and I'll never forget this little kid that I was working with. He introduced me to his mom, and he said, this is Mr. Lewis. He's the director of what did he say? Gosh, it was so funny. Destructive, yeah. This is Mr. Lewis. He's the director of destructive innovation. And I went, close enough, you know. And so what we actually did in disruptive innovation, I used to say, we looked at what all the other telecoms were doing, and we opted to invert it, right? And so Let's actually look at the problem that they're trying to solve. Let's take a step back. Let's invert the path. Let's find a better way to done, faster way to done. That's more meaningful. And I love the story behind Netflix, right? So Netflix was a disruptor, and the other telecoms like AT&T and Verizon were like really kind of set back on their heels because they were looking again. We're in the bandwidth business in telecom, and so how can we sell more bandwidth? Movies take a lot of bandwidth. We'll sell streaming content, and then Netflix comes in with this codec, that this compression algorithm that just eliminates the need. So we're watching movies over 3G on a cell phone, and the other telecoms are like, there goes our big idea, right? And so my job was to upset the other guys and come up with technology that inverted their big idea. And so but everything was problem driven, right? So I go back to use case. What is a problem that we're trying to solve? And I'll tell you, one of the coolest things that we've done is I worked in the long range Wi-Fi. It was very disconcerting that my cell phone, I lived in rural Louisiana, and it was a 36-mile drive to my office. And I switched to a cell phone provider. Again, I'm not going to say the name because I don't want them to think that I'm saying negative things about them. But, in my drive to work, 36 miles, I had no signal. There was one stoplight halfway between that I had like 10 feet of signal. So if I ever broke down, it'd have to be right there because I wouldn't be able to call for help on my cell phone. And then when I got to my office, not very much signal. I had to be on Wi-Fi. And so I was like, if I could extend Wi-Fi for 30 something miles, I could have complete coverage the whole way to my office and the whole way home. That was my motivator. And so I created a long range Wi-Fi program using commercial off-the-shelf radios. And so, I was building long range Wi-Fi for a couple $100, and getting phenomenal bandwidth. The challenge was though, that you had to align these radios, and we were experimenting at like 60 plus miles, in anything further than a mile, you really can't see the other radio. So it's like, how do we align these things? And so one of my patents, I worked with a bunch of students, and it's their patent. My name happens to be on it, but we worked with them, to build these automated gimbals. And the radios would give off a signal, and we used a specific type of diode and you can go read the patent, it's public knowledge. But it would read the signal coming off the radio, and the diodes would go, where's the strongest signal? And it would move the radio until it got the strongest signal, and it'd do on both ends, auto aligning these radios at 60 plus miles. You couldn't even see the other end. But it's like, hey, look, my lights are all lined up. We're perfectly aligned. How do you do that? Yeah, magic. So stuff like that. So I always enjoyed, doing things like that. So
I love that fascinating, again, problem-driven and solution-driven approach, and creating disruption and destruction at the same time,
yeah.
but making things better. What are some other patents that you're so proud
Okay.
of? That
So
you've
I'll tell you,
contributed to?
so I was getting ready to give a talk on quantum, and I was trying to figure out how, quantum and its impact on security, and how do I describe quantum? And it was funny, as I was whiteboarding, I love whiteboards. In fact, there's a whiteboard behind me. As I was whiteboarding out, my talk, that came up. I ended up building a transient state computing device that in my little prototype, I could manage 127. No, and the prototype was 91. I could manage 91 bit states using color. And so it's like, okay, I want to be able to quantum. I really didn't understand quantum at the time, but I thought of quantum as being able to manage multiple bit states simultaneously. Not entirely right, but I was new at this. So I was explaining quantum as, so it's like colors. And so if you go back to your primary color wheel, green represents 3 states simultaneously. Red is on, blue is off, blue is on, and yellow is on. So green is blue and yellow. So red is off, blue is on, yellow is on. I was like, wait, that's not exactly how quantum works, but I could build a transient state computing device that used light and color. So I built a photo optic CPU. And then if you start looking at, well, if I use the primary color wheel, that's red, blue, and yellow, I can manage factorial states, right? So 6 states simultaneously. If I added a secondary color wheel, then I can do 27 states simultaneously. Then I add a tertiary color wheel. Now I'm up to 91 states, bit states simultaneously. And so I'll never forget, because I had this little prototype and we were doing the patent. And so I'd taken the shrink wrap tubing off of my little prototype. And so in the corner of my little lab, we had all these blinky lights. And our CTO came in and he says, "What's up with all the blinky lights?" And so I said, "That is a transient state computing device. It's a photo optic CPU." And he said, "We're a telecom. Why should that matter to me?" And I should have answered, "Because we have a very large fiber footprint, and I've made our fiber footprint into one giant CPU." But unfortunately, that wasn't my answer. So my project got canceled, but still got the patent on it. It's an amazing patent. It's out there in public domain. And so the way that we did that, the challenge and the cool part about the patent wasn't the actual blending of the light to manage simultaneous bit states. It's on the other side, and the use of a prism in order to separate out those bit states back to their independent values, right? And so that was something DARPA was working on as well, as far as like, how do you use light to represent data? And so anyway, so that was one of the cool. Another was, so we have all this equipment in our houses, and all of it has CPUs. And so I was thinking, man, if I could take all of that and build a giant computing device, using the internet and then the internet speeds, putting all of these CPUs together, unused cores, and then using that to build a supercomputer. And so we did that. So my boss walked into my lab and he's like, "What's up with all the DSL lines?" And I said, "Oh, well, so that was kind of interesting as well." So I think those are probably the most fun. I think the last one, okay, so I also said that I didn't quite understand quantum. And so while I was at the university, I was doing some research into Lorentz force. And it turns out that if you use zinc as a conductor, something very interesting happens at a quantum level. And so there's a really interesting patent out there using zinc because what it allows is the qubits. So in quantum is all about qubits, and the problem that we have with quantum is that those qubits are kind of like children, tanked up on sugar and caffeine. And so when you try to put qubits together, they repel, right? And so getting them all together, so a qubit is only represents a very small amount of data. And so you have to put a bunch of qubits together in order to have the computational complexity to make them useful. And so they repel each other, so you can't get them together. Then when you do get them together, there's noise. And so interpreting the value of the qubits, on a non-deterministic scale. And then the other thing is that they're spinning and they're non-deterministic. And quantum computers are much more like analog computers. And so one of the things that I did with zinc is zinc changes the way the qubits behave. And instead of spinning and stopping in a non-deterministic fashion, they now become deterministic. So they vacillate between a 0 and a 1, which means that now I have a quantum processor that's working at the quantum level deterministically, like a digital computer, instead of non-deterministically, like an analog computer. And so that was one of the things that I was working on at the university, and there's a patent on that. And that is probably by far the coolest discovery that I've made.
That is, again, fascinating to me and for everybody watching and listening. I know it's hard to understand implications of these innovative solutions, but what's so beautiful is, again, that we have creative minds like Ron that can truly not only see what is lacking, what's missing, and knowing and understanding what's already on the market and finding those creative solutions that are going to create a ripple effect and impact of years and decades to come. And which I'm sure you're already thinking of the next solution and knowing how your brilliant mind works. But I'm also fascinated that, Ron, that you're also a phenomenal musician. You're playing a lot of different instruments. You're able to also conduct yourself not only with visual stuff and connecting the dots of complexity of technology, but also with musical notes, with the sounds, and what is happening in that side of your passion.
So I'll tell you what my wife told me. An accident-prone guy should never be a drummer. These are wise words. So, I love music. My father was a jazz musician, and music was just kind of what we did as a family, and it was part of just how we communicated. We didn't communicate very well unless it was musically, and so we, as a family, we would play together, and you often hear the team that plays together stays together. Same thing with a family. And so my dad, really focused on teaching us to play guitar. And so I studied classical guitar. I'm terrible at classical guitar. And I'll tell you that as a guitarist, as long as I've been playing, I should be a lot better than I am, really. But I enjoy it. I do a lot of music creation. I'm terrible with lyrics, and so I do a little bit of songwriting, but most of my time is spent doing recording and putting things together, right? I love taking a theme. It's kind of like with technology, right? You take one theme and then you weave a bunch of stuff around it and you come up with this beautiful tapestry of sound. And so and I'm still kind of, I'm going through this self-discovery. I mean, I've done a lot, I change careers every couple of years. And so that's one thing that I think is super important, right? Always be growing, always be learning, always stretch yourself, you know. Now that might not be good for your spouse who's always worried about, it's like, okay, what are we doing now? Right. My wife is extremely patient, I'm very fortunate, but, always learn. And so like you'll see behind me, I don't know if you can see it, but I've got a steel drum behind me because I'm learning to play steel drums. I love island music. I have ever since I visited the Caribbean, I've been in love with island music. And so teaching myself to play steel drums and keyboard, and so love making music. So thank you for asking. So
Absolutely. And for everybody watching and listening, I know you have some recording done where they can also find that information and listen to some of your beautiful tunes.
okay, yeah. So I'll send my SoundCloud. Caveat with SoundCloud. So there's a lot out there as I'm going through the self-discovery. Every track out there has a story behind it. So like when I was in the Caribbean, I don't drink a lot. I don't drink now at all. But I was sitting in on the beach next to the woods, and I had a little thing of beer from the beer vendor, and a monkey came out and sat down next to me. And as odd as that sounds, and my wife goes, that monkey was trained by the beer vendor, right? Because the monkey shared my beer, and I was suddenly surrounded by monkeys. It's crazy. But anyway, so there's tracks out there, and every track has a story behind it. So like if you see the track "The Drunk Monkeys, Don't Be Offended," that's about me drinking with the monkeys, right? And so the whole soundscape is me describing that experience in sound. And so you'll see a lot of everything that's out there. The instrumentals all tell a story, and I'm trying to tell the story through sound instead of words. So
I
and
love
maybe
that.
your listeners can tell me how well I did. Maybe you just
Fantastic. We'll make sure that they get the link and they can also consume not only obviously this amazing wealth of knowledge that you're sharing in this episode, but also obviously some of your work and opportunity to also connect. But before we go there, do you mind sharing in closing your perspective of everything you've done? Obviously, you led and you lived and led your legacy, and you already left tremendous legacy for previous encounters through companies you work, from patents you created and complex solutions you solved. Thank you for listening to Legacy Leader Show. If you enjoyed the content and had a positive experience, then please leave us a positive rating. In addition, leave us a positive review whenever you are listening on whatever platform there might be. Make sure your friends and family also know about the benefit and value that we provide and what we have to offer. Cheers.